All right. Hello, everybody. I think we're going to start a couple minutes early tonight. Hope you all are well. I am not really at the moment. Still kind of in a migraine hangover. I had a migraine for most of the day. Hasn't completely subsided, but I'm going to give this a shot and see how it goes. Worst case scenario, if I don't wind up feeling well, I'll just end the stream early. But I figured I would hop on and try to knock out some stuff tonight. So, hey Tammin, how's it going? Welcome, welcome. So, we're going to pick up tonight on our terrain work and see if we can't get our height map rendering the way that it should. But before we do that, I do want to take a second actually and just make a quick call out that the YouTube channel did hit 10,000 subscribers actually yesterday. So that is kind of awesome. I really appreciate all the support there from each and every one of you that has subscribed over there. And if you're watching here and you want to see the rest of the series or any of the archives, I would encourage you to head over there. It's at youtube.com/TravisVroman. So I've had that YouTube channel, I think, since 2018 is when 2018, 2017 is when I really started uploading stuff, I want to say. With a few small things uploaded way back in like 2009. But yeah, it's come a long way. It's kind of cool to see how it's grown. So thank you for that. If you're not feeling okay, maybe it's a good idea to do some planning. Yeah, I might do that because I do have some additional stuff that I want to plan out. But we got really close on the terrain stuff the other night, so I kind of want to step into that. I've taken some notes on some things I was thinking about off stream that it might be. And so I'm going to go ahead and step through those and see where we wind up. Let me just grab my notes, speaking of those, right here. So the first thing I want to check is do sort of a quick sanity check and just make sure that nothing is appearing in the logs. That might give it away as to what the actual issue is. So I'm going to actually use tmux tonight instead of trying to work in have a single console terminal rather over here. I'll use this for code and I'll just switch back and forth for a terminal. So I'm going to exit this and we'll use this for code. The other thing that I'm trying tonight is I'm trying a little bit of a new feature in OBS that allows me to put this viewport of my camera here in front of everything else so I can actually see what you guys see. So hopefully I shouldn't be blocking anything that you guys can't see. I'm going to adjust this a little bit actually. So now what I see is what you guys see. So we'll see how that works. All right. So when we left off, we had terrains are only loading as a single triangle, which I don't think is 100% true. I think it's just failing at some point. So I'm going to go ahead and swap over to this tab, and I'm going to go ahead and build all, just to make sure that we are in a neutral position here. I'm also going to do a post build, just to make sure that all of our shaders are good to go. So that looks good. So let me go ahead and run this real quick. Run the test bed, and we'll see what kind of maybe error logging we get. I'm going to move this over so we can actually see this a little bit maybe. I'm probably just going to take a look at the console logs to be honest, but let's go ahead and load this. And I saw something up there, terrain failed to load. So we are definitely getting some stuff in the console. If I move this and open that up, let's have a look and see what we're getting here. So, terrain fish failed to initialize. Tile count X cannot be less than 1. And then Vulkan renderer create geometry requires vertex data and none was supplied. So it looks like we have a few things going on here. And I actually suspect that this first one might be the fallout of all of that. So tile count X cannot be less than 1. So my question would be, why is tile count x less than 1. So let's go ahead and let's exit this and have a look. So this is our terrain loader. I'm not 100% sure I'm going to need that right now. What I really need is my terrain C file. So in initialize, we are it looks like our create is not really doing much of anything except taking a copy of the config, and then we're using that config and initialize to copy over a whole bunch of stuff. I do see tile count X and tile count Z are being copied from the config. So that seems to be happening. So I don't think that's the actual problem. Let's look at the loader real quick. So we do have tile scale X, tile scale Z, and then scale Y. Oh, you know what? I actually don't see scale Y being copied, so that's going to be a problem. Scale, do we not have scale? How are we not copying the Y scale? Okay, so this actually leads me to something else that I got thinking about. So when we actually load one of these terrains, we have this pattern where we are sort of setting up this this resource data, we populate it, and then we write that out, right? And then we read it in elsewhere. So, for example, our image resource, we read our resource, we do what we need to with it, and then we throw out the resource by system resource system unload rather. And so I'm thinking this might be part of our problem. It might actually be happening in simple scene. Simple scene when we are loading terrain. So let me just go to here where we're actually loading up the resource. So we're loading up the terrain resource. Whoops. Where did that go? Yeah, here. Okay. So we are we're loading up the terrain resource. We are parsing out the config. We do create the terrain, set the transform, and then we unload the resource. So I'm wondering if we're unloading something here that we shouldn't be. So if I look at the unloader for this, so we'll do terrain loader. When we go to unload it, we are destroying the vertex data's D-array. The problem with that is, if we look back, we are only doing create here, right? But we're still nuking that array. But initialize is what actually needs the array. So I think we probably need to change up our paradigm a little bit in how we're doing this. And I think instead of holding on to the config and then just passing that to initialize to figure out like what we need to set up here, I'm thinking we should probably just copy these values directly to the terrain object so that we always have it. That way we can throw out the config and not have to worry about it. Because I think that's actually causing half of our problems here. So when we go to create a terrain, let's go to definition. We are keeping a copy of the config. And we see here that we also are, we have a name, which we also have in the config. We have a tile count X and Z, which we are already copying over. We have a scale X and Z, which we're copying over. The only things that we're not keeping is the scale Y, the vertex data length, and the vertex data themselves. We are actually, well, in the material count and the material names, which here is material count and materials. So what I'm actually thinking of doing is, instead of doing this, where we're keeping the config, since we're already keeping most of this stuff anyways, I'm going to take all of this stuff and put it, I guess, right here. I want extents down here, actually, next to origin. Okay, so now we'll have the scale y, the vertex data length, and the vertex data. And what we'll do is we'll take a copy of that array. That way we don't have to worry about the life cycle of the config and all that stuff. How did I learn so much about game engine dev? It seems you have a pretty clear picture of how all the systems should look like at the end. Have you worked on an engine team before? Yes, I actually have. So at the game company that I worked for a number of years, I actually had a hand in re-architecting the initial engine that they had, and then I led the architecture of the new engine that they set up there. And that was nothing. That wasn't quite as complex as what we're actually building here. That was for 2D games, but most of the concepts are actually relatively the same. I also spend a lot of time looking through engine code. So ever since Unreal went open source, and actually even before that, I worked on some closed source projects that were on Unreal 3, and I've been looking at the architecture of their engine for many, many years. And I've also looked at some other engines and done a lot of reading and research on it because I'm a giant nerd and I love these kind of things. And so, yeah, I've been tinkering around with game engines for a number of years. But yeah, I've written 2 front end game engines professionally, and then I also wrote a server backend as well. So that would be where most of that comes from. Okay. So we have material counts. I'm going to keep a copy of the material names as well. I don't remember if I set that up as a D array. But here it's just going to be a flat array because I don't need a D array at this point. So this array here and this, let's see, the vertex data is going to be a flat array. And I think the vertices is also a flat array. And if it's not, I'm going to make it one. Because there's no reason really to change the size of those things. So we don't really need the D array overhead for any of that stuff. We also have the vertex count and so forth here. So I'll double check those things as well. But if we do that, then we no longer have to care about how or when this config is loaded or not loaded or what have you. So I'm going to go ahead and save that and jump back to terrain C. And instead of keeping the config, we are going to basically take everything down here where we are copying stuff out of the config. So we'll do this. Actually, why are we recreating the transform? I thought we're actually loading that over here. So that's wrong. We should be copying that from config. Actually, yeah, we shouldn't even be doing this over here. That should actually be here, I think. All right, so let's stick with one thing at a time here. So let's go here. We will paste this here. This is going to be just config. Right. These are just sanity checks. So, Bolsa, thank you so much for the follow. I appreciate that. Thank you. Okay, so we have our tile counts. This should not be happening. Scene config. I think this is the actual new terrain. Doesn't the terrain config also have transform? I think, because we should be setting it there. We shouldn't really be setting this directly here. So we do not have transform here, but we probably should. So we should probably be setting, we're doing this directly here. We probably shouldn't be doing that. So let's go ahead and change that as well. So I'm going to call this transform, if I can spell it, xform. And we also have that here, which is just going to be, actually, do we? Yes, we do. So we have that there. This really should be parsed config. Parsed config dot xform. Is it train config? Why is that not picking that up? Equals scene config sub I. Oh wait, config terrains sub I xform. So why? Terrain config. Why is this bleeding? This should go away. Oh. That might be why. I called it xform, I thought. Does this really not have struct terrain config? I'm looking at it. Right, maybe this is one of those things where I have to build it. Do I not have... I do have math types, which should have the transform here. That is in math types, yep. Okay, so I should have that. I'm not sure why IntelliSense is bleating about this, but we'll cross that bridge if we need to later on. Okay, so terrain create. That's the other thing is terrain create is taking a copy of the config, which I think is kind of dumb as well. So I'm actually going to change that up as well. This should take a, realistically, a const pointer to the config. And then we don't need to do this dereference here. We could just pass the parsed config. And then up here, we can change this to be a constant pointer config. And then we can change these guys to just be arrow operators. All right. Okay. Oh, and this one also. Okay. So that should do that. Let's continue moving these. So the terrain xform, that copy should really be done up here. Out terrain xform equals config xform. I realize that's an extra copy, but this way it's a little bit cleaner. Let's see. We just catch up on chat here. That's cool. I developed a passion for game engines. Pun intended. Yep, I get that. And want to do it professionally. Lack of experience is getting in the way, though. Absolutely. Yeah, it's a difficult field to get into for sure. And thanks for the congrats on the 10K subs. I appreciate that. Cool. So we have that copied over. We can get rid of this. I suppose we could move this to create as well. In all of these, yeah, we are creating standard arrays for these, so that's fine. So I'm going to cut these and paste them here. And then we'll just have to out terrain extents Let's see. So I guess we could just leave extents at 0 for right now. We probably ought to slap a to-do on here, though. Calculate based on actual terrain dimensions. Just so I don't forget to do that. Out terrain. Oops. Okay, so you know what? I'm going to out terrain tile count x is, instead of tconfig, it's just going to be config. So we'll just get rid of these guys, and then change these over to arrow pointers, or arrow operators rather. So it's that migraine hangover kicking in, and I just can't word tonight, apparently. So we got out terrain, tile count x, tile count z. So we copy those over from config. We want to also copy over out terrain scale x and out terrain scale z. And I think we said we weren't copying the y, so we need to go ahead and do that as well. Out terrain scale y equals config scale y. All right. Okay, so this is going to be out terrain I'm just going to paste this a few times and then come back and oops, right there. Wow, why is that? Why has it done that? Okay, apparently my typing abilities are also terrible tonight. So we have out terrain. All right, the vertices is allocated here. Here's the indices. Right, here is the actual array of those. We need index count, so all right, material counts. Material count will be fine. Materials and material names are going to be something we're going to have to copy. So we want to say out terrain material count. If we have that, then we're going to say out terrain materials, out terrain material count. All right, I'm going to copy pasta this and also do material names. And this is going to be an array of character arrays. Okay, so we should be good there. Out terrain materials, and then we'll also do this out terrain material names equals 0. Right, so if we don't have any, we'll just do that. Okay, so those things are all copied over. What is this bleating about? Oh. Vertex count. Let's actually move this up to one line so that we don't have that weird breaking going all over the place. Okay, so vertex, index, material arrays. The only other thing that I believe we have to add is the vertex datas, right? Which right now just contains height. So we'll say out terrain, vertex data length, which actually this is technically the same thing as the vertex count. So I might actually get rid of this, but for right now, I'm just going to set it to be the same thing. Vertex count. And then out terrain vertex datas equals k allocate. The size is going to be a size of terrain vertex data times out terrain vertex data length, and we're going to memory tag array that. Right? So we've got those. I think that's most of the material, or most of the configuration copied over. All right. So at this point, we shouldn't actually... Oh, there is one step I forgot. I actually need to copy that over. So k copy memory. The destination is going to be out terrain vertex datas. The source is going to be config vertex datas. And the size is going to be config vertex data length times size of vertex data, terrain vertex data, rather. Right? So we'll take a copy of that there. That way we don't have to worry about that in the future. Why is this erroring? What did we forget? Size EOF? Yeah, that's not sure what I was typing there. Okay. All right. Material count. Oh, this is not supposed to be out terrain. This should just be config. Material count. Okay. Cool. So, that is everything from there. I think the only other things that we're doing in here are all no longer config driven, except for this guy. So this just needs to go away and just be vertex data's height. Speaking of height, we are, might need to be in the right loader here. Terrain loader. When we're loading the heights in here somewhere, right here, we are scaling the heights. So we're basically taking, and I'm actually thinking the way that we're doing this is probably not 100% correct. So we're scaling this by 255 to basically take this to a range of 1 to 0. We're taking the average between all of these things, which I don't think is 100% correct. We should probably be taking the additive result. So I'm going to get rid of this divide by 3, because I don't think that that is what we should be doing. I think we should just scale it by 255 for now, because I think that's going to make it too flat. So we'll adjust that scale there, and then here the height. We're not actually doing anything with the scale Y that's configured. So we actually need to multiply this by the terrain scale Y, right? Just to make sure that that gets taken into account. Okay. So we're doing that. Then we're generating normals, generating tangents. I think all of that should be fine for right now. Let's see. What else? I remember we were getting zeros for the tile count X and Z. So let me just make sure that we are actually reading those in. So we have the resource data, tile scale X, Y, Z, here. Okay. We read it in the heightmap file. We set the vertex data length. We set up the array for the vertex datas, but we don't actually use the image width or height to actually set those things. So that's actually a bug. So we're forgetting to do that too. That's probably why we're getting the 0, right? Because we are copying it from the config over here, but it's never actually set in the config here. So this should be resource data, tile count X should be, we're going to use the image data width. Whoops. We use the image data width for that. And then resource data tile count Z. We're going to use the image data height. Yeah. So basically, we're just going to scale the terrain to be the same size as the number of pixels we have in our height map, and that's how we're gonna do it. By the way, last time you were wondering about the plural of data because of vertex data. It should be vertices data. No. Yes, but it's a collection of vertex data, but it's not vertices themselves. So it's yes and no. I think it's one of those weird, awkward English things where it just doesn't, there's no right solution for it. I should probably come up with a different word than data, I guess. Vertices datas. Yeah, exactly. Oh, I hate naming sometimes. All right. Let's go ahead and build this. And run and see what kind of skullduggery is afoot. So we'll load this up. And we don't see anything yet. We still have the same result, which leads me to believe that we didn't fix the entire problem. Let me move this so we can actually see it. So let's just look in here. Okay, so now we have a different set of errors. Free list find block. No block with free enough space found requested. Blah, blah, blah bytes available. Vulkan render create geometry failed to allocate from the vertex buffer. Terrain failed to load. Okay. I'll bet I know what that is too, actually. So, more than likely, if you recall, am I using a VM to code this? Nope. No, this is my local, my native OS. Yeah, there's no VM here. So if you recall way, way, way back when we initially were standing up all the Vulkan stuff, we sort of made some assumptions on how much data we were going to need for our vertex and index buffer. And now that I think about it, like we're loading a crap ton of vertex and index data for this terrain because it's a huge height map, right? And so more than likely, we're probably overflowing that. Even though we're not loading the Sponza right now, I think we're probably still overflowing it, just because of the amount of data we actually have to represent the terrain. So if I recall correctly, I think I've moved most of that stuff to the back end for now. So Vulkan back end. And if we take a look at, let's see, what vertex, vertex buffer size. This is exactly what we need here, actually. So this is actually, looking back on this, is a bit of a weird assumption. So our vertex buffer size is size of vertex 3D times 1024 times 1024. And that's probably not going to be big enough, right? Because I can tell you right now, this is not going to be enough to hold all the vertices that we need for the terrain. So to keep from completely blowing out the memory, I think I'm going to just increase this by a factor of 10, right? And we should probably revisit this and make this configurable, right? But for right now, I'm just going to increase that by a factor of 10. Now, the other thing is down here, the index buffer size, I suspect is also going to need to be increased. But this is only the size of U32s, but we have way more indices than we do vertices. So I'm actually thinking I'm going to increase the size of this 100-fold for right now. And I'm also going to put a to-do, make this configurable. And we might want to actually put something in place to be able to resize this. I'm not sure what that's going to screw with when we do that, so we may have to be careful with that. But the render buffers do have the ability to be resized, so we might actually want to dynamically change that at some point. But for now, I'm just going to try this and see what we get. So I'm going to write this, build again. Meager, thank you so much for the follow. I appreciate it. Let's go to run this and see what we get. So we'll load and spin around and woohoo. All right, cool. So we have a massive, massive terrain. In fact, we actually can't even see the whole thing. It may be a little bit hard to make out on stream, but if we look way back here in the distance, it looks like it's actually being clipped, right? Which actually makes sense, because our height map is 2048 pixels by 2048 pixels, and our default far clip, if I recall, I think we just set it at 1,000. And since we're doing a 1-to-1 ratio on this, it would make sense that that's being cut off. But before we fix that, I do want to call out that we do actually have height data here. It's relatively flat, right? It's a little hard to see. But if we kind of move along the directional light here, you can kind of see where that is. So we obviously need to increase some of our settings here a little bit for our height map generation, right? Because it's almost flat. It's not quite flat. You can kind of see it, but we need to make it a little bit more obvious. So let's do, where do I even set those perspectives? Where are we setting perspective matrices? So we're setting one on render view, world on resize. That's the default one, okay, that we set up. That's just a source. So it looks like we're also doing it for the skybox, which we don't need to modify that because the skybox doesn't have to actually go very far, so we can leave that one alone. The picking is also going to need to be changed, because if we don't change that along with the render one, then we're going to wonder why we can't pick far away objects. So we need to update that one. And the rest of these are all just the definitions. So what we'll do is we have data far clip. So we just need to change that guy. So far Here we go. So we've set that to 1000. And again, we have a to-do here to configure this, but I'm just going to cheat for now because I don't really want to mess with it, right? There's a lot of work that we need to do to be able to actually configure this. In fact, we might be able to configure this from the simple scene and just have the simple scene call out and set this, but for right now, this is what we're going to do. So the other one was the pick, I believe. Yeah, so far clip. So that's the UI far clip. We don't want to change that one. World shader info far clip. Do we not have? We're not setting that anywhere here. I can't see how that'd be possible. Here's all the UI shader info. World shader. Oh, here it is. Okay, I just hadn't gotten to it yet. Okay, so change that to 4000. Okay, so that should allow us to see it a little bit better. So I guess I can just build this real quick and take a look at the change. So load this. Obviously, parsing this does take a little bit of time, so we're gonna want to multi-thread this for sure. But if we go up here with our camera and look off in the distance, we can now see the whole thing. So what we need to do now is go ahead and adjust the height. So let's open the K-terrain file. And we have a scale of Y that is currently set to 1. Let's scale that up to, I don't know, 10. Just to get something a little bit more extreme. Hopefully that's enough, actually. And we can actually just run. We don't need to rebuild because that's just configuration. All right, and load. And spin around. I probably ought to change my default camera settings, but here we go. So that's a little bit better, a little bit easier to see anyway. It's not perfect. We probably need a little bit bigger of a scale on that. Let's crank this up to, I don't know. Let's crank this up to maybe 50. 50 is probably going to be too much. But there we go. Okay, so now we can kind of see what we're looking at. I still don't think that's enough scale-wise, but at least, you know, we can visibly see here what we're dealing with, right? So we've got all of our terrain. It looks like it's mostly responding to lighting correctly. We do have a lot of pretty extreme stepping going on here, so I'm not sure whether that is our map doing that to us or whether we have an issue with our normal generation or our geometry. Let's get a little bit closer here. Have you considered using an inverted infinite Z projection? No, I don't see how that would help. In fact, it would probably mess some things up, like some stuff in my library if I were to actually change that. So the short answer is no. So it looks like we've got a little bit of weird, kind of stepping going on here. So let me see. I actually went ahead and downloaded some different Heightmaps. So we can try one of these things. What did I call them? Let's see. So we have Terrain Heightmap, which is what we're using now. We have Terrain Heightmap 2 and 3. Let's try, I think 3 was a completely different one. So I'm going to write that and run. Let's try this with a different map, right? And I'll show you guys the map here in a second, what that actually looks like. So, whoa, yeah, so different height maps are actually going to need different scales, right? So this one, the height on that is way too extreme, so you actually can't tell what it is. So let me back this back down to 10. And get rid of the file browser. And we'll load. Okay. So that's a little bit better. This one is actually a map of England, right? So we can see we've got our mountain ranges here, right? It's obviously way scaled down, but this looks a lot better. So I think our stepping issue might have just been the height map that we were using. The only thing is like with a height map, you're naturally going to get sort of that step effect. So we might be able to add something in to be able to like smooth it out a little bit, to maybe make it a little bit better. But as we can see here, just using a different, smoother height map might also make a huge difference. So cool. That's actually a really big step in the right direction. So let me see here. What other notes do I have for changes for tonight? I think I've actually hit most of these things. There was one other thing I wanted to hit, actually. So let's go ahead and exit this. And in terrain, .c, in load, we are incrementing the terrain geometry generation here. And I'm not sure why I did that, because render geometry create does that. So if we look at the, is it the front end or the back end that does that? I don't remember whether it was the front end. If we take a look at geometry create, it's got to be the back end, okay. Geometry create. Here we go. I believe geometry create actually does this for us as well. So after we load everything into the buffers, here we are right here. So we're actually doing the internal data generation increment there. The internal data is the... Wait, are we only doing internal data though? Maybe that's why. So the Vulkan geometry data has its generation. Maybe we actually aren't. We're not. But I feel like the client code shouldn't have to worry about that. Let me see how many places are actually doing this, right? Because it's probably going to be G generation plus plus anywhere we look. There's 2 places. So create geometry does it in the geometry system. And then our terrain does it. Let's see, we're taking the config. We're also doing extents here. So we might want to change that as well. Trying to decide if I want to bite that off for now. I'm going to say no. What I am going to do is put a to-do. Offload generation increments to front end. Also do this in geometry system create. I'll come back to it another time. Okay. So now we have our height map working, which is awesome. We've tried a couple different height maps. We can configure it in the scene. So I guess the next portion of this is probably going to be the multi-material portion of it, is what I'm thinking next. Which that's going to take a little bit of planning, I think, because we need to think about how we're going to apply multiple materials. And so I don't know that we're actually going to even dive into that tonight, just because we might dive into like some of the planning, but the actual code, I'm not sure. So I think the first thing is get status. Let's go ahead and push up what we have so you guys can at least have the code. So we'll say height map terrain generation complete. And we'll push this to our branch. All right, cool. So what we're going to wind up having to do is currently our material system has this concept of, oops, let me go back. Let's see. Has this this notion of applying global and instance level uniforms, right? And so our global level ones for materials are your projection matrix, your view, your ambient color, view position, render mode, things like that, which is all fine. And I may not deviate from that. The problem is where we have multiple. Let me move this up so you guys can see behind me here. In fact, I'm going to close this one. So the problem becomes where we are using multiple materials. So right now, our material locations basically account for one material, right? So we have a diffuse color, diffuse texture, specular, a normal texture. And then we also have a shininess. And then for each one of those things, we also have lighting that gets applied. So we have directional lighting and point lights. I don't anticipate that these will change. In fact, the code for those was already moved over to the terrain rendering logic. So I don't anticipate any issues with that. But we need to be able to apply multiples of these. And to apply multiples of those, that indicates that we need to basically have a set of uniforms for each individual material. Now, we could do this sort of the naive way and just say, well, we have material 0, material 1, material 2, things of that nature. And we can just set them to those indices and have an array of materials that we assign and then just mix them that way. And in fact, we may wind up doing it that way. The problem with doing it that way is there are only so many materials that you can actually have bound at once, right? There's an upper limit of how many materials you can have. So in this case, I probably wouldn't want to exceed 4 because of the amount of textures we're going to have to bind. So for each material, we're going to have to bind a diffuse, specular, and normal map. And then we're going to have to mix those things together, right? And so we can't have too many samplers out all at once because there is a limit on how many samplers we can actually use at once. And particularly if we want to support other APIs, such as OpenGL, there are limitations on that, right? And so we have to kind of think about that. And generally speaking, you never really want to go over about 16. and that's basically how many are bound per draw call. And so we could realistically get away with, I'm going to say 4 materials, because we're eventually also going to have an emissive map to make things glow a little bit, and we might want that on the material for some reason. And so I'm going to say that we're going to have a limit of 4 materials, which means that our terrain, at least initially, is going to be limited to 4 materials. And then we'll basically implement this, get it working, and then see how that works. And then we'll change it up to something a little bit more advanced later that can allow us to have many more. There's several ways of doing that. Sorry about the sirens going on in the back, if you guys can hear that. OpenGL has 32, I think, texture limit, but Vulkan and... Yeah. Well, so it's not unlimited, though, because the thing is, it's limited by what the actual GPU will support, right? So there can be a vast variety of how many are supported there, right? And bear in mind, if we have, if we have a lot of other materials that are also being used in the scene that are descriptors of their own, like there's only so many things that you can have going at once, right? So we're probably going to implement this the naive way first so that you guys can kind of understand the concept, and then we'll refactor it into something that's a little bit more robust afterwards. I'm trying to decide whether I want to start this tonight or not. I guess we could start by looking at the shader itself. So if we just look in here, let me collapse some of this stuff. Which one do we want to... The lowest tier of Direct 3D is 1 million. Yeah. And I don't recall what some of those limits were in Vulkan. I'll have to pull up the actual, we'll pull up the spec, and we'll pull up what my card here supports at some point when we actually go to tackle that. But yeah, I'm also thinking about mobile devices, right? Samplers would be a problem, so only 16, but you don't need a sampler per descriptor. No, you don't. You don't have to use combined ones. That's what we're using right now, but we don't have to do it that way. But I'm also trying to think about mobile devices right now. That's part of the reason that I haven't stepped up to 1.3 and used the extensions to allow us to get rid of render passes and stuff like that, is because I'm still hoping to be able to support mobile devices at one day. I may wind up dispensing with that. I haven't decided. And if I do, then we'll be in much better shape for stuff like this, I suppose. I'll have to do some hard thinking on that. I suppose I could put up a poll at some point. Probably not here, but on YouTube or something like that, and just take a vote to see how many of you guys are actually interested in seeing this run on a mobile environment versus just one of the major 3 desktop environments. Or maybe on mobile I just say screw it and we use OpenGL on mobile. I don't know. All right, what was I doing? So I guess we're going to look at the terrain. We're going to need the fragment shader. Did I already rip out all the sampler stuff? No, I commented out. Cool. Angry Bit Games, thank you so much for the follow. I appreciate it. All right. So the naive way to do this is we'll basically have we'll basically use this. But instead of samplers, max terrain materials, let's see, which I actually had set 8 here. I'm going to reduce that to 4. So So we'll basically have a bunch of samplers here. 3 because we have diffuse, specular, and normal. And then I guess we also need to set up, we're going to need to set up some, well, let's see. Should we make these global uniforms? I still don't think we're going to need instance uniforms because we're not really rendering instances of this. So there are properties like shininess, for example, where there's one of these per material. So it's one of these and one of these per material. So we'd probably need to swap that out. Although I remember we reordered some of this stuff, I think, because of alignment. So we're going to have to be careful with that. So we probably need to set up a structure. It's probably going to be the best way to do this. So, I guess we could say struct. And we'll call the structure type material info, I guess. And in that, we will have, in that we will have vec4 diffuse color. We'll have a float for shininess. We obviously have our samplers down below. That can't be all the material info that we're going to have. I feel like I'm missing something. Let's look at... Might not be missing anything, actually. That might be as simple as that. It might just need to be a bunch of these things. That might actually be it. For now. Till we add more properties, obviously. Okay, I guess that is it. So that's actually not too bad. All right. It does make me think I might actually have to pad that out to make it align nicely. I'm pretty sure I'm going to have to do that. Let me just do that. And then diffuse color goes away, shininess goes away. But then we should be able to, since that's padded out nicely, we should be able to say material info. Materials, and then max terrain materials. All right. And that should give us what we need for that. All right. So the next thing that we're going to have to do is basically come in here and mix our materials together. So we have our... Oh. Yeah, this is going to be interesting. Because, if you recall, we actually have our texture sampling going on here for our point light and for our directional light. Because the normal map has to be taken into account. So that means that we're going to have to actually calculate this and sample it for each individual material. And then we're also going to need to know a weight of those materials for the given vertex. So we're actually going to have a little bit more data here. Let that was one thing that I was forgetting to include here. So material info, we should probably put the weight in here. So we'll say float weight. Do we want that in here? No, that's going to be a vertex attribute, actually. Ignore me. Okay. So that is something we're going to have to add to our vertex attributes. Is weights for each material, right? So we're going to need some floats for that, because that is how we are going to basically mix all of these samples together. So no matter what we do, we're going to have to basically take in and calculate all the directional and all the point lights for each individual material using samples of its textures, and then add all that stuff up and mix it at the end. And that is basically the naive way of doing it, right? And it will work. It's not going to be performant. There's a lot of things that we can do to enhance the performance of this in the future. Eventually, we're going to be switching to a different lighting model, which will also help with that. But we're still not there yet. So, all right. I guess the next part of this is to figure out how we want to actually tackle this. So we're going to say the max terrain materials right now is going to be 4. We do need a count in here of how many materials we actually have, or maybe we always just say there has to be 4 materials. And then we could just not assign it, I guess. I don't know, that seems crappy too. Let's do int num materials. And that way we can loop through this way. Okay. So we're basically going to need to do, let's see, 2 was normals only. So the normal is just that. I need to run this real quick because I forgot what was 1 and what was 2. Let me run this real fast. I think 1 was the normals mode. No, 1 was lighting mode, 2 is normals mode. This is my different rendering modes. Okay. So, get out of this one. So if we're in 2, we don't really have to, we're not calculating any lights in 2, right? Because we're just doing this. But that does need to take into account the normal map. So how is that actually getting, oh, because we're hard coding that here. Right. So this whole thing is going to actually have to be surrounded in loop for each material. So what we're going to wind up actually having to do is for int, make sure we're not using I anywhere else. We are here. So I'm going to say m for material equals 0. M is less than global UBO num materials. Whoops. Global UBO num materials plus M. All right. And we'll come down here and we'll wrap this entire thing. That also means that we're going to have to obviously indent all this stuff. probably a quicker way to do this, but I'm not familiar with what it is off the top of my head. All right. So we need to use the sample from the normal map. So the local normal is going to be our samplers. But that's going to be... So the way we're going to line these samplers up is going to basically be diffuse, let's say diffuse, normal, no, specular, normal, diffuse, spec, normal, etc. Right? That's how we're going to line those up. So basically what we need to do is just basically take these offsets here that we're going to define and then multiply them by the current index, and that should give us what we need. So I'm just going to uncomment these. And samp normal offset is what we're going to use here. So this is just going to be called offset, and we're going to multiply that by m. And that should allow us to index into that. And that'll give us that. We also normalize that. And I think that should be good. Now, I thought I saw in here that we're like sampling things multiple times, which we probably shouldn't be doing, right? We have the diffuse sampler in here, the specular sampler in here, and then diffuse and specular again here for each one of these things. So we probably ought to modify these functions to actually take in those sampled values so that we only actually do that once. So I'll just add that to the end here. We'll say diff samp and back for spec samp. And the normal we're already actually passing through. So we should be good. Okay. Smudge, hello. Welcome. Sentient Cloud. First of all, hello. Unrelated to the current stream topic, but there's an easy way to get detectable auto repeat on Linux without having it affect the whole X server using xgit. Yeah, so that's that's a section of code I actually really need to revisit. Because yeah, the auto repeat stuff, like if I kill the application without letting it shut down gracefully, then my keyboard repeats stop working because it's global. And that sucks. So yeah, that's definitely something that I need to fix. Do you happen to know what that way is? Because I'm not all that familiar with that stuff. I've kind of messed with it a little bit, but I've not done tons of programming against it. And in fact, actually, if you do have an idea about that, if you could drop it in the Discord server, just so that I have a note of it later and I don't lose it sort of in the chat here, that would be awesome. I would really appreciate that. Okay, so we're actually going to need to do the same thing here. So vec4 diff samp and vec4 spec samp. Okay, so actually I'm just going to copy this and put it there and there. Okay, and then basically I'm just going to take this bit and come up here and vec3. I'll call this diff samp. Oh, it's a vector 3. Am I not taking the... No, it should be a vector 4. What am I doing? It should be a vector 4. I need the alpha. put that in there, and then I'm just going to duplicate that and say spec samp, right? And then this is going to be samplers. We'll say samp diffuse offset times M. And this will be samp spec offset times M, right? And now we have those samples only being taken once. And we can pass those in here. So we have, for our directional light, diff samp and spec samp, right? And then for the point lights, diff samp spec samp, which means that we can now get rid of this line and where am I taking the sample here? Am I not taking? I thought I was. Oh, it's down here. So I can just say spec samp here, and then delete to the end of the line, right? And that keeps us from doing that more than once. So, oh, did I nuke diff samp up here? Yes, I did, because I just used that. Okay, that's fine. So that goes away. And then this is going to wind up being spec samp. Okay. So that should use the one from each material. Now there is a couple things, like we have shininess that we haven't swapped over yet. So we probably ought to pass that structure through is what I'm thinking, instead of the index and trying to index it. We should probably just pass material info through. So we're going to need material info. I guess I could just call it mat info. And then we'll come down here and do the same thing. Material info, mat info. And then similar to before, I can just copy pasta this, slam that there, and then wherever we are pulling the shininess, let's go ahead and, highlight all of those. So here we can change word to mat info shininess. And I think that's just going to be the same thing here. So mat info shininess. And I think that's actually all the places it's used. Okay. So the next thing is going to be diffuse color. So diffuse color. Right. So we're going to change this to mat info diffuse color. And the directional light's the only one that uses that. So I'm not 100% sure that's correct. Well, I guess it's correct because they get added together. So yeah, that's fine. All right. So that's that. And then what we'll need to do here is just pass through our global global UBO dot, what did I call that? Materials. Yeah, just that materials. Dot materials sub M. And then the same thing here. Global UBO dot materials sub M.
All right. And then we actually need to take into account the weight of this, right? Because this is right now what this is doing is just sort of adding all this stuff together. So that's not going to be great either. And so we need material weights to modify all of this stuff and actually mix it together instead. And I can never remember the syntax for mix. So I think it's just a, let me actually bring this on the screen so you guys can see it. So this is basically, it's going to work the same anywhere, right? We have mix, different types, but we provide an X and a Y and then a value, which I believe is 0 to 1. Yep. Okay. So we should be able to use that to actually mix between materials. So the thing that we need to mix is, let me think about this. It's going to be the sample is what we actually want to mix. I'm thinking about this now, actually. I don't think we actually have to do... I don't think we actually have to do this bit every single time. I think what we really need to do is actually just mix these and then pass the mixed value to this and only calculate the light once. Because if we mix the normal maps together already, when we pass that through, that should give us the result that we are looking for. If we just mix it ahead of time. So actually, the only other thing that we have to consider is the shininess, which I guess we could mix as well. And the diffuse color, I suppose. So thinking about that, we could actually save ourselves a lot of logic by doing that. Instead of trying to mix the result, I think we could just mix this and then mix the material stuff itself. I'm thinking if that's going to work. It actually does make a lot of sense to do that. So I guess let's try that. I don't think we're going to, like I said, I don't know if we're going to be able to see this run tonight anyways. We'll see. So let's take all of this out of here and put it here. Test it and see if it breaks it. Yeah, exactly. That's what I'm thinking. Philip, thank you so much for the raid. I really appreciate that. Raiding with a party of 28. That's awesome. Thank you. And welcome. So, for those of you who are new to the stream or haven't seen this before, of course, raiders, welcome. So what we're doing here is we are building a game engine from the ground up in C, and we're using Vulkan as our rendering backend, at least for now. We've designed it in a way where we can support multiple backends. So right now, we have sort of this plugin architecture that we've got, and we've implemented a Vulkan renderer plugin, but the plan is to eventually support other rendering APIs like OpenGL and DirectX and probably Metal at some point. So we do have, yeah, it's native dev, yeah, native engine dev. So right now I'm actually I'm running on Arch Linux, but we do support Windows and Mac OS desktop natively right now. So we have cross-platform support. If you are interested in a little bit more about the engine, let me bring the website up real quick, just so you guys can be aware of what the project is. So there is kohiengine.com, which is basically where all of our info about the engine is. So you can find all the YouTube info, the Twitch, the GitHub repo. This whole thing, I should mention, is open source. So everything here is completely open source. So you guys can look through the code as we sort of are developing the engine. This project's been underway for about 2 years. I've done the entire thing on, it started off as a YouTube series, and it has since sort of translated into being a live stream series. I started that earlier this year. So we're up to about 100 episodes. Actually, I think it's about 108 episodes now. 108, 110, something like that. And yeah, we've come quite a long way. We have obviously lots and lots to do, but we do have quite a lot done, right? So we started from the bare bones at the very lowest of low levels and are sort of building everything up. We're also doing all of this without libraries, with the exception of 2 libraries. So those 2 libraries are, if we go here to our engine, and then source and vendor, I'm using STB image for image loading and STB TrueType for font loading. Those are the only 2 libraries I'm actually using right now. So everything else here is rolled completely from scratch. So I think that catches us up. So this is designed to be an interactive stream. So if any of you guys have any questions, please hop into the chat, and I will answer them to the best of my ability. Yeah, so there we have it. Cool. So what we're working on right now is we are implementing terrain. So I've put in, we just got Heightmap terrain working, and I'm currently breaking the shader, although I haven't recompiled it, so it might actually run. So let me go to terrain. Let me just kick off the debug so you guys can kind of see a little bit of what we have going. So we have the ability to load and unload scenes dynamically. And so we just got some not Skybox. I'm looking at the Skybox and thinking Skybox. So we just got Heightmap terrain working, right? And so now what we're in the process of is actually developing a multi-material system to go ahead and be able to slap materials onto this and get it rendering. Because right now all we can see is basic lighting information and then normals, right? So we do have basic meshes working here. So I have like a test little mesh here, so you can see it in normal mode. And then also we can always have our debug modes that shows just lighting, and then the normals. So what we're doing right now is we're just building out our terrain material system. So tonight's stream is a little bit of a different one, because I'm actually, ironically, on a bit of a migraine hangover, so I'm not quite as sharp as I normally would be. So I'm just kind of tinkering around with stuff tonight, and I decided to go ahead and start tackling some of the terrain generation. Wavelength, I'm super tired today. Unproductive day. Yeah, that was just totally me. I wound up actually sleeping a decent portion of the day because I get migraines, and it affects my vision, and I couldn't see for a decent portion of the day. So I'm only just now getting to the point where I can actually kind of sort of function normally. All right, so let me just... I really need to get an auto formatter for my GLSL, because this is doing this manual business is not great. All right, so what we're basically doing right now is a super naive multi-material implementation where we basically have a sampler array of material bindings or texture bindings. So we have a diffuse, a specular, and a normal. And so basically the way that we're going to bind those in the back end is diffuse, spec, normal, diffuse, spec, normal. And then we have these offsets here. And then we have multiple materials that can be bound, which is here. And then we have a max number of those things. And so we just obtain the sampler out of the array by looking at the offset times a multiple, right? And that should give us what we need. And by doing this, we only should have to sample these things once, and then we're working on passing that to our existing lighting code in order to make it do what we need to do. So I hope all of that makes sense. Okay, so like I said, if you guys have any questions, feel free to drop in the chat and I'll answer them. TNT, hello, welcome back. Yeah, it has been a minute since I've seen you here. Welcome. Yeah, it's we're in the middle of terrain materials now, so been busy with the university exams. Yeah, that's important. You definitely got to focus on that for sure. All right, so what we were talking about right before the raid was actually doing a mix on these. So we need to have some sort of weight applied for each material, right? So we have these samplers, we have various material properties, such as shininess, diffuse color, so forth. We're eventually going to add more. I just have some padding here so that it has proper alignment. But we actually need to actually add something to our vertex data to actually give us a collection of material weights. In other words, how much of material index 0 should we apply versus material index 3, right? And so now we're just supporting 4 materials. We are going to obviously up that. We're just doing a super naive implementation right now, and then we'll make it a little bit more robust and performant once we get it working. The whole point of this is also to be a little bit educational. So for those of you who just joined, the whole idea behind this entire stream and the YouTube series is to show a way of building a game engine. It's certainly not the only way. It might not even be the best way, but it is a way. And it is a resource that I kind of wish I had when I was learning how to do this stuff, right? So that is the reason for all of this stuff to exist. So let's look at the vertex shader. Because up until now, we've had sort of the same vertex layout where we have position, normal, text coordinate, a color that we can pass potentially, and then a tangent. And up until now, that has been enough, but now we are actually going to have to add another thing to our vertex information. And that is going to be layout location equals 5. Oops, 5. And we're going to say that's an N. Let's see. What do we have here? So we have vector 3, vector 3, vector 2. So that's one block. Tangent is vector 3. We may have to pad that out to a vector 4 in order to achieve 16-bit alignment, I think. 16-byte alignment, rather. So we may have to pad this out. But for now, I'm going to pretend like that's not an issue. And I'm just going to put in a vec4 in mat weights. And we can do this because we have 4 materials max. If we had, we'd obviously need another one of these or some larger array of floats to support more than that. But because we're only supporting 4, this should be fine for now. Supports 4 materials. All right. So there's our new weights. And we don't really need those here. We need to toss those over to the fragment shader. So here's our data transfer object, of which we have another on the opposite side. So I should be able to just tack in vector 4. Let me call this material weights. Oops. Material weights. And I could just pipe that over down here. Yeah, I'll do it right here. So out DTO dot mat weights equals global UBO. I think I called it mat weights up here, didn't I? Or no, it's not global UBO. What am I talking about? It's in mat weights. Right, so we'll take that out of our vertex data, pass it over to our fragment shader, which it's DTO. Where is it? Here's our DTO on this side. So we'll say vec for mat weights. And we can then just use those to line up with our material ID, right? Or our material index, rather. So I think I'm thinking the way to do this is probably the best way to do this. I'm thinking is probably an iterative approach, to just sort of add it to whatever is currently there. And then they should add up to 1 by the time we're done. Do I want to do that in a loop though, or maybe I should hard code it and just unroll a loop and do it that way? It might make it a little bit easier. This seems a little bit cleaner though. So let's go ahead and let's say, I guess we could do a mix of diffuse sampler and you know what? I'm not going to do it this way. Just thinking about that, that's probably not going to be the best way to do it. So instead of using this, so this is our normal value here. Let me expand this a little bit. And actually, let me open this over here, actually, because my big head is in the way. Fragment GLSL. So let's go over here and we'll just do this sort of the unrolled loop way. So I wonder if I can, if I should nest these. Local normal. Let's call this why are we overwriting this normal actually? So we're taking that normal. And we're completely nuking it. Why are we doing that? Local normal. I mean, I suppose that's fine, but it's a little bit strange. I'm going to say vec3. Maybe I should make an array of these things. Actually. Maybe that's the way to go. So vec3 normals. And I'll set this to, oh, what did I call that? Max terrain materials. Right? And then I can set, do we use local normal anywhere else? I don't think so. I don't think we do. We just pass normal. Okay. So let's refactor this a little bit to say normalize all of that. And then we can say normals sub 0 is equal to that. And then we don't. Oh, you know what? I forgot the TBN, so that's going to be a problem. So I need to have the TBN in there. TBN times that. Now I can get rid of this. And now I can have this, actually. Right, and then I can say M. That makes more sense. Okay, so we just slam them all into an array. Got to head out, but this is looking promising. Best of luck. Thank you again. I appreciate it. I really appreciate the raid. Thank you so much. And yeah, hope to see you back sometime soon, for sure. In fact, I am going to go ahead and toss you a follow as we speak. So thank you again so much for the raid. I really appreciate it. Okay. So I guess, yeah, let's follow this pattern because I think that's going to make it easier to mix. So we'll say vec for diffuses. It's another one of those plural things. Max terrain materials. And then vec for specs, max terrain materials. And then we can basically just move this up here, move this up here. All right, and then diffuses sub M and specs sub M. There. Okay. That feels better. Okay. So now that we have an array of those things, we should be able to mix these all and come up with the final value that we're going to wind up passing into these light calculations. Because if we mix these things ahead of time, that means we only have to sample them once, and then we take the already mixed value, pass it into those functions, and then we should have what we need. I'm really tempted to just like nest mixing calls. I'm not 100% sure that's the right way to go, but now we can say diffuses sub-0, diffuses sub-1. Oh, but how am I gonna use the weight for that? I wonder if I just stack those, if it'll give me what I need to do. So maybe if I just do it up here. Vec diff. Let's start this off with zeros. I'm not 100% sure that's what I'm going to want to do, but spec equals vec 4 0. Start these off with black, and then diff equals mix diff with diffuses, which actually now I'm thinking we probably don't even need to keep that array, but I'm going to keep it for right now anyway. And then say in DTO weights, material weights rather, sub m. Oh, this needs to be diffuses sub m. So if we do that for each one of these, then I think we might have what we need. So maybe I'll just say vec 4 norm equals vec 4. I may have to crank up render doc to see if this is actually going to work the way I think it's going to work. But what I'm thinking is, word norm, if we combine them this way, TNT, I have to go leave now. Happy streaming. All right, cool. Thanks for stopping by. Appreciate it. And good luck with your exams. Let's see. So change word. In this case, I'm going to do spec. And then spec. And then specs sub m. So again, I might not need these arrays. I might just wind up throwing those out, but this should give us a mixed value of those maps. And then we pass the material info, and instead of normal here, we just pass norm. Then we have view direction, diff sampler, so we just pass diff and then spec. And then this should be much the same thing. So we have diff and spec, and then norm. Okay. So on this side, that should give us what we need, I believe. I think we've modified all these functions to do what we need them to do as well, I believe. So we should be okay. I'm going to do a post build though and see what I've screwed up syntactically. I'm sure there's going to be something. No matching overloaded function found. Does mix not work the way that I thought it did? I could have swore that you could use it on a vector 4. Yeah, you can. So why is it GLSL 93? So we have the norm. Oh, wait a minute. Norm is a vector 4. Oh, that's why. Because this should be a vector 3. Build. Okay. M undeclared identifier, line 102. Oh, right. Because I have to mix those things as well. The material properties. So I can't just pass the structure unless I create a new structure and mix the values that way, which I suppose I could do. So that's going to be for the shininess and the diffuse color. Not to be confused with the diffuse sample. I guess I could say material info. And I guess I can just call this matte. Or just, yeah, matte. Matte dot, I don't want to do this. Matte dot diffuse colored, matte dot shininess. So we need to set that to a vector 4. Again, I'm going to start with zeros. I don't know if that's the way to go or not. Shininess. I'm going to start that with 1.0. Maybe I should start this with 1s. I don't know. We'll see. We'll try it and see. Could do it in one line probably. Yeah. I'm just, I'm trying to do it the way that's most clear to me at the moment, and then I'll kind of come back and clean it up when I'm done. So matte dot diffuse color equals mix, and then we need was it global? No, it was yeah, it was global UBO. Global UBO dot materials sub M diffuse color. And then we want to use matte dot diffuse color. And then we want to interpolate those by in DTO. Mat weights sub m. Okay, and then we'll also do this for shininess. 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 All right. So in theory, we should be able to then just pass this guy. So mat, I think is what we called it. Yep. So we need mat. And mat. And that should give us the pre-mixed value across the board. Hello, the Silver. Thank you so much for the follow. I appreciate it. Okay. Let's see if this builds yet. Builds. Okay, sweet. So now what we need to do is we need to tell the engine what our layout is. So I'm going to need to go to the shader config for terrain and modify this. GGMon, thank you so much for the follow. I appreciate it. Okay. So we have a few things here to shift around. I guess let's tackle the samplers first. So we have these guys commented out. We can go ahead and add those in. I guess we could call this... Diffuse texture 0. Specular texture 0. The name here really doesn't matter, right? It's just for like debugging purposes. And then we'll just paste a few copies of this, right? We need 4, right? And so this is 1. Oops. Why do I have a comma there that shouldn't be there? All right. This is 2, 2, 2. Get rid of the comma. 3, 3, 3. Get rid of the comma. Okay. So that's all of our samplers. Like I said, this is the naive way of doing it, right? This is the simplest way to get it up and running. We will do this much better. Vector 3 norm equals vector 3 mix 0. Yeah. So I could, I definitely could mix them all in one line. I feel like this is a little bit easier to understand when you're looking at the code. Because the other thing is like I want to be able to dynamically just change the number of materials later on and not have to rewrite that code. I'm hoping. Because the other thing is we do have a count of those things. So if I did it all in one line, I would always have to use 4 materials. Whereas this way I could just use 2 or even 1. Okay. And I might have those mixed statements backwards, by the way. I may have to flip those. I can't remember which way it actually does it. Does the thing. Okay, so that's our samplers. So they're all global. We've got that. The next thing that we need to do is, let's see, projection view model, ambient color, view position, mode, those can all stay the same. Sentient Cloud, thank you so much for the follow. I appreciate that. You're gonna leave. Have a good one. Yeah, you too. Definitely. I'm about to wrap up actually here for the night too. So the stream's just about over for tonight actually. Okay. So I really just want to kind of finish up this configuration. That way next time we can sort of pick up on the binding of all this stuff next time around. So let's see, diffuse color. Diffuse color is one of those things that's going to have to move. So we're going to need like a structure like this. How did I set this up in our global uniform object? So we have projection view model, ambient color, view position mode, which is right there. And then we have material info. So material info is going to be a struct. So, and it's going to have, let's see, how did we do this before? So our directional light was a struct 32. And this is also going to wind up being a struct 32 because it's 32 bytes, right? So struct 32. We're going to call this, we'll call this material info, right? And that's technically an array of those things, which actually, that's not a struct 32. That's going to have to be, they're 32 a piece. And we can have up to 4 of them. So I am going to have to hard code this in here. Let's see. So that's going to actually wind up being, what, 128. Right, because there's an array of them. I probably need to enhance this format so I don't have to sit here and figure this out, but that's fine for now. So that's our material info. Then we have our directional light. Then we have our point lights, which is an array as well. And then the number of point lights is here. The shininess is part of this material info, but we do need a new counter for our materials. So I'm going to change this to I32 and then change this to number materials. Okay. So that should be, nope, it's not quite all the configuration change we need. So we need the terrain vert GLSL. Because remember, we actually have to add these mat weights, right? So here we actually have new attribute to add. So this is going to be a vec4, and we're going to call this in mat weights. And I'm going to add a note here. Might have to pad the above for alignment. Okay. All right, so this should tell the engine what the format of the pipeline should need, and all of our samplers and all that stuff. So now all we should have to do is actually bind them in the terrain code. So I'm actually going to leave a left off. Need to bind these locations and attribute in the terrain code. All right. And we have actually reached the limit of our time tonight. So we will pick this up in the next stream. We made some decent progress tonight. Most of our progress was, of course, getting Heightmaps to work, but we've also, I think, knocked out a decent chunk of our shader logic that we need to do. So we've done this part. We need to make a few modifications within the code side to actually support these changes here. But yeah, given the state of my brain today with migraine hangover and whatnot, I'm surprised I made as much progress as I did. So, Alphonse, yeah, you're funny. I haven't forgotten about that either. So yeah, I think that's going to do it for tonight. Let me go ahead and choose a channel to raid. I think you guys probably know what channel I'm going to select here, but um, I'm going to raid Ferret Software. So for those of you who are on my channel, I raid this channel a lot. It's basically a bunch of ferrets that belong to Pirate Software, and basically he's got this 24-hour stream that runs that he uses the ad revenue and whatnot to pay for the ferrets' medical care and stuff like that. And ferrets are awesome to watch; they're super cute. And so I tend to raid this channel a lot, and I'm going to do so tonight. So I want to thank all of you guys so much for tuning in and following along and interacting. And I would encourage you guys, if you haven't already, to just follow this channel. Check out my YouTube channel, which is Travis Vroman on YouTube. I just recently hit 10,000 subscribers on there, which is a pretty sweet milestone. That's pretty cool. Never thought that I would hit that for sure. But yeah, go ahead and check that out for all my other content. And of course, all of this series will be on there as well. And with that, yeah, I bid you guys good night. Thank you so much for watching, and I will catch you guys next time.